Alright folks, here we have another practice problem for neutralization reactions. Notice this time we're dealing with a weak acid and a strong base. Now here's what you need to try to understand. We can still make water right here because this acid has hydrogen in the front and this base has hydroxide parts. Okay, so we're still in luck, we can still make water, but our ionic and net ionic equations are going to look a little bit different in the end just because we don't have strong acids and strong bases. So let's get started. Write down the parts again. You've got H2CO3, which is carbonic acid, plus LiOH, which is lithium hydroxide, and we're looking for their products. Now, I would go ahead and label this. This is a strong base. This is a weak acid. Okay, now we need to get our scratch work written down so we can think about this. Okay, now anytime you're doing scratch work, you want to write the ions down, even for weak acids, because you need to be able to think about how the products are going to be made and what they're being made from. Just remember that technically weak acids, they do dissociate partially, meaning they do slightly break down into ions, but not completely, meaning you got a large chunk of this carbonic acid still floating in the water, but you do still make a little bit of hydrogen ions and a little bit of carbonate ions, just not that much. Anyway, for thought process and getting our answers, you want to do some scratch work where you think of all the ions. So here, what I'm getting at is, we know that we've got a hydrogen ion. Don't worry about balancing it right now. We're just trying to think of what ions are present when these things go into the water. Okay, so we've got H plus 1, and we'll have carbonate, which is CO3 negative 2. Okay, that's how I got it from the formula. You know, this 2 is actually the charge up here. There's a dot number behind the 3, so that was a 1 for the hydrogen. Plus lithium, which is Li plus 1, and OH negative 1. And if you want to, go ahead and put all your pluses in there, but sometimes I do, sometimes I don't, because this is just scratch work. This is thought process. Okay, now I'm going to try to see what product I can make and which two I can make. Here I can make water again because, hey, I've got hydroxide ions and hydrogen ions that can still give me water. So I'm going to place them together so I can make water. It's always nice when you can make water because it cuts down on confusion. So that's why I love seeing hydroxides in a neutralization reaction. Okay. Anyway, I'm going to put this lithium ion with this carbonate ion. Now, after you get that, come up here and write your products. That gives us water, H2O. That's a liquid. And this right here would give me Li2CO3. Just remember that the 2 comes down behind the Li, makes that subscript. The 1 goes down behind the 3, which we really don't even write ones, but it's there. That's why you can't see it. Now, let's go ahead and write the complete, and make sure that once you write the complete, it's balanced. We've got H2CO3 and LiOH yielding water, which is H2O, and don't forget to write L for liquid, and the Li2CO3. Now balancing it, well, let's see, hydrogens, I know they're not balanced because I see 2 here, and here I see 3. But let's focus on the lithium first, because that'll probably help us balance everything out. Since this is a 2 here, then we need a 2 here. And that gives us 2 lithiums, 2 lithiums. Now that also gives you 2 hydrogens and 2 hydrogens, so that's 4. So we need to put a 2 in front of this water, because that will now give us 4 hydrogens. Now, what about oxygens? Well, oxygens, you've got 3 here, 2 here, so that's 5 on this side. Over here, that's 2 oxygens, and 3 oxygens is 5. So we're balanced on lithiums, we're balanced on hydrogens, and we're balanced on oxygen, so that just leaves carbon. We've got 1 carbon, 1 carbon, we're balanced. Alright, let's get the ionic. Now, be careful here. Here's the rule. If they're weak acids, when you get ready to write the ionic equation, you do not dissociate them into ions. So this will stay intact, H2CO3, because we do not break down into ions weak acids. Okay, that's why I left it intact here. This carbonic acid, I did not break it apart because they do not dissociate 100%, so we do not break it down in the ionic equation. Now in my scratch work up here, I did that so we could get our product, so we could see where everything was coming from. That's the only reason I did it up here in the scratch work. But remember, your scratch work is never graded. What's graded is what you put on the line for complete, what you put on the line for ionic, and what you put on the line for net. But I like to show my students where this water is coming from, where this salt will be coming from. That's why I still break them down to ions in my scratch work. Now, this one you're forced to break down because this is a strong base. So you've got two lithiums here, but remember, lithium is a +1 charge, so make sure you write that down. And for all those that are listening, remember that this is aqueous. Okay? And then plus, there's two OHs, so you write down 2 OH, but what's the charge on OH? It's -1. Yields, we've got two waters here, so that's 2H2O. Notice I did not break down the water. Plus, and this lithium carbonate is actually soluble as well, and that's 2 Li+1s, and, running out of room, and this CO3 -2. Now if you look around, notice that you have 2 Li+1 on both sides, so that's a spectator ion, and you should have 2 hydroxides, but over here you don't see them, and you should see CO3 -2 over here, but you don't see them over there. So you only have one spectator ion, that's Li+1. So we'll get ready to write that down later, but let's go ahead and get the net. So your net ionic equation is what you didn't mark out. That's the H2CO3 plus the 2 OH -1s, yielding our two waters, our two H2O's liquids, and the CO3 -2 ion. Our spectator ion will be just Li+1, because that was the only thing that we marked out. Alright guys, I hope this helps. Just watch it a few times, try to get it in your head, but just remember that when you get ready to write the ionic and net ionic equations, that you do not dissociate weak acids or weak bases. You do not dissociate water into ions in these dissociation equations, or basically neutralization reactions. So just remember that. Alright guys.